Okay, here's warm up 11.4. I've got a 30, 60, 90 triangle here. I'm going to solve for x and y. And you could actually find an x and y with SOHCAHTOA, but it wouldn't be in simple radical form. So if you want to use simple radical form, you have to use the special right triangle relationship. Okay, so the short leg is going to be across from the 30-degree angle, so I'm going to put SL for short leg. The long leg is going to be across from the 60-degree angle, and then this is my hypotenuse across from the right angle. Okay, so I've got the long leg, so I want to always get the short leg first if I don't have it to begin with. So I'm going to get it from the long leg. So since it's getting smaller going from long leg to short leg, so I'm going to be dividing, and here I'm going to be dividing by the square root of 3. So x is going to equal 5 divided by the square root of 3. I'm going to write that as a fraction like so. Okay. And then I need to rationalize the denominator. I can't have a radical in the denominator. So there's no twins that I can get out of the radical there, so I'm going to clone a twin for the 3 like that. So I just do the same thing at the top. Then I'm really just multiplying it by 1. Right? I'm changing its form, but not its value. So on top I have 5 root 3. On bottom, with those 3's under the same roof, then I do have some twins, so one of them gets out. So I've got 5 root 3 over 3, or that's the square root of 9. That's another way to think about that. Okay, so that's what x equals. X equals 5 root 3 over 3. Okay, once you've got the short leg, we're going to multiply to get the hypotenuse because it's getting bigger, and we're going to multiply it by 2. We're doubling it. So if this was 5 root 3 over 3, I'm thinking, okay, I'm multiplying this by 2, so think of multiplying by 2 over 1. You're really just doubling the numerator then. So this is going to be 10 root 3 over 3, not 10 root 3 over 6. Don't multiply by 2 over 2. Multiply by 2 over 1. And there we go. Okay. Now the next problem, this should have a degree symbol here. Okay, so the next problem, this is not a special right triangle. This missing angle would be 50 degrees, but that's not one of my special right triangles. But I still can use SOHCAHTOA. So SOHCAHTOA, you want to put yourself at the acute angle that's marked. So I want to be down there, and I'm thinking, what pieces am I dealing with? Well, I've got this leg over here. That's the opposite leg because it's across the triangle. This would be the adjacent leg down here, but that's not marked. And then I've got the hypotenuse. Okay. So then thinking of SOHCAHTOA, I need to decide what part of SOHCAHTOA am I going to use. I want to use the one that uses opposite and hypotenuse, and that would be the sine part. So I'm going to set up a sine function. So sine, I need to say where I am. I'm at the 40-degree angle. Okay, and then I'm going to do opposite over hypotenuse. So opposite would be x, hypotenuse would be 7. Okay, and then I'm going to solve this for x, so I want to get rid of the fraction here. I can do that like so. Okay, and now I've got something that I can put into my calculator. 7 times the sine of 40 degrees. Okay, and you want to make sure that you're in degree mode on your calculator. I'm just going to check mine. Yep, I am in degree mode. I just hit the mode button there. Okay, so then I'll type in 7 times the sine of 40 degrees. I'm going to the nearest hundredth here, so I'm going to call that, I'm going to round that to 4.50. Okay. All right, so next up, this is a regular hexagon. So regular means that all the sides and all of the angles are congruent. So hey, I've already got this side. That means all of the sides are going to be 10. Okay, all right, so good to know. I just put that in the picture. Let's start by finding x here. If you think about x, well, x, this is one piece of pizza here. It's a weird shaped pizza, I know, but it's one full slice of pizza. And if you think about how many full slices there are like that, there's 6 of them, right? 1, 2, 3, 4, 5. This slice is cut in half, 6. So if I want this angle, this is going to be 1/6 of the entire circle. Okay, so to get x, I'm going to take 360 and divide it by 6. The whole circle is 360. So x is going to be 60 degrees. Or I guess I don't need the degree symbol because it's in the diagram there. So yeah, let me write it like that. So x equals 60. Okay, And we can do the same kind of thing down here. These two half slices are going to be congruent to each other, these two triangles, because we could use HL. There's a number of ways we could show that these are going to be congruent triangles. So this would be a right angle right here. So these spokes are all going to be congruent in a regular hexagon. And then, so if these two spokes are congruent, and then this would be congruent to itself by reflexive, and then we've got ourselves HL right there. Okay, so what I'm getting at here is that, hey, if these two angles are congruent to each other, well, I know together that's a total of 60 degrees there, so that means y is going to be 30 degrees because y is half of 60, right? It's just my angle in the middle of the pizza for a half slice, okay? So then looking at this, this triangle I have here, this is going to be a 30, 60, 90. Okay, that's good to know, because 30, 90, this would have to be 60, all right? But let's see what else we can do. So we know these two half slices are congruent, which would mean that, hey, those are congruent, and if they add up to 10, then z would have to be 5. Okay, I should have put my answers down here, but that's okay. I'm finding x, y, and z. Okay, so now I know that this is 5. Okay, this is in a 30, 60, 90. Hey, this is my short leg, right? So going from short leg to long leg, well, let's look over here. Short leg to long leg, well, we went in the opposite direction. We divided by √3, but if we're going from short to long, we'd multiply by √3. So then w is going to be 5 times the square root of 3, which means 5√3. Okay. So then I've got my variables down here. X is 60, y is 30, z is 5, and w is 5√3. Okay. So next up, I'm going to find the perimeter. Perimeter is the distance all the way around the outside. So hey, those are all 10s. So I'm just going to think, how many slices are there? There's 6 slices. 10 plus 10 plus 10 plus 10 plus 10 plus 10. Or you can just do some quick multiplication, and that's going to give me 60. And this is in inches. I don't want square inches because this is still just a distance that you can measure with a ruler. Okay? And then the last piece, I've got this area. So there's a formula for regular polygons, for the area of regular polygons, that looks like this. Okay, P is going to be the perimeter. Hey, that's nice because I just found the perimeter. Okay, the A part is going to be the apothem, and so that is going to be the distance from the center to one of the sides. So it's the perpendicular distance to the sides. Okay, this would be a radius here, but I don't want a radius. I want this this part. This is my apothem. Okay, so now I have the components that I need. So my area is going to equal 1/2 of 5√3 times 60. Okay, so 1/2 times 60 would be 30, right? 30 times 5 is going to be 150, so this is 150√3. So you could leave it like that. It's that many square inches, or decimal approximation. It's going to put us at 259.81 square inches if you're going to the nearest hundredth, okay? And that's the end of the warm-up, and I'll see you next time.